Good afternoon. Once again, welcome for our second lecture in pharmaceutical engineering, and which is based on the size reduction topic. In first lecture, we have discussed the introductory part of size reduction, how the size reduction is carried out with the help of different mechanisms of size reduction and objectives of size reduction we have already covered. Now, in next lecture, we will cover the equipments which are used for size reduction, that is mills. So before actually going to proceeding to the equipments, we will first of all discuss how size reduction is actually occurs, means how the breakdown of particle takes place. So size reduction means what, that we have already covered. Size reduction means the coarse powder particles are break, results in a formation of fine powder particles. So this process is known as size reduction. And why size reduction is carried out, that objectives also we have covered in first video lecture. Now next we will see how the size reduction of the actual particle takes place. So powder, solid powder material are either crystalline or amorphous. These are two different types of solid, either crystalline powder or amorphous powder material. So both crystalline and amorphous powder material, so these powder particles are irregular shape powder particle. For example, this is one powder particle. The shape of the powder particle is irregular powder particle. So this is one powder particle. We will see with the help of one representative example. Now these powder particles, either crystalline or amorphous, these powder particles consist of the flaws on the surface. What is mean by flaws? Flaws means the imperfections which are present on the surface of the particle. So these imperfections are later on responsible for actually the breakdown of the powder particles. So once the powder material subjected to the impact, what is meant by impact, that already we have covered. So powder material is heated by the moving object of the equipment. So when this powder particle is heated by the moving object of the equipment, let's say hammers, or in case of ball mill, balls, then what will happen, these flaws which are present on the surface, these flaws in presence of the impact, these flaws develop into the cracks. So initially the flaws are present in presence of the impact, the flaws converted into the cracks, and later on continued impact results in a breakdown of the particle at the cracks and results in a formation of many powder particles like this. So simply the flaws grows, results in a formation of cracks, and these cracks results in a breakdown of the powder particle. Now you can see here this powder particle has broken down into many powder particles due to the impact. So firstly impact is responsible to develop the cracks, and later on the breakdown of the powder particles takes place. So this entire size reduction process is carried out with the help of equipments, and the equipment which is utilized for size reduction is known as mills. So many mills are utilized in the pharmaceutical industry. So we will discuss the classification of the mill. So mills are divided into four different type, broad type. The first type is a grinder. So grinders include the example hammer mill, later on ball mill, next roller mill, and fluid energy mill. These are four types of grinders. Second type of mill is crushers. Crushers actually break the powder particle by compression force. So example is edge runner mill, and next is end runner mill. These are two types of mill. Later on we will discuss the construction principle working of all these mills. Next is ultra fine grinders. So ultra fine grinders, these are responsible for production of fine powder particle. The example is fluid energy mill. Ultra fine powder particles you will get which have size in nanometer range. And last is the size reduction mill, which is based on the cutting mechanism. Already we have discussed the mechanisms of size reduction. Mechanisms, the one of the mechanism is cutting. So which mill is based on the cutting mechanism? It is cutter mill. So these are four basic types of mills. One by one we will discuss the construction principle, working advantages and disadvantages of individual mill. So later on we will see the different size reduction mills along with the mechanism of size reduction and particle size produced by this particular mill. This table is very much important because the questions may ask in multiple choice questions based on this particular table. So which is the mechanism of roller mill? Which of the following is current mechanism of hammer mill? Likewise question may ask in a semester examination. That's why this table is very much important. So first mill is roller mill. Roller mill based on the compression mechanism, it compresses the powder particles and results in a breakdown of the powder particle. What about the size range produced? 50 to 10,000 micrometer size. Later on hammer mill based on the impact, then colloidal mill, attrition, ball mill and fluid energy mill. These both mills work on both mechanism, attrition and impact, combination of attrition and impact in case of both mill. And last is cutter mill, the mechanism is cutting. Now you can see here the size of the powder particle or material which is produced by the cutter mill is very much coarse because it is just responsible for cutting of the material, and it is most commonly used for cutting of the different parts of medicinal plants. So cutter mill produce the very much coarse powder material, whereas you can see the colloidal mill produce very much small powder particles, 1 to 50 micrometer powder particles are produced. So that's why this table is very much important, and you must remember that all powder particle size which is produced by particular mill as well as the mechanisms of size reduction. One by one we will start with the mills. We will discuss principle, construction, working advantages and disadvantages of individual mill. So first mill is hammer mill. Hammer mill works on the principle of impact. What is meant by impact, that already we have discussed. So hammer mill consists of, as such name suggests, hammer mill consists of hammers, and these hammers are connected to central rotating shaft. So this central rotating shaft, or which is also known as rotor, and this rotor is connected with different hammers like this. These hammers are made up of stainless steel. So likewise hammers are present. The hammers are available in different shapes again. So this hammer rotate at high speed, and due to high speed rotation of the hammers, what will happen? If the particle comes in contact with the hammers, what will happen? Hammers strike on the particle at high speed and results in the impact on the particle, and this impact is responsible for breakdown of the powder particle into fine powder particles. So high speed hammer strike on the powder particles results in a breakdown of the powder particle. So stationary powder particle is heated by the moving object. Which is the name of moving object? Hammers. So hammers are responsible for breakdown of the powder particles. So here the impact which is generated by the moving hammers, this impact is responsible for breakdown of powder particle, and at the bottom of the hammer wheel the sieve has fitted. So powder particles remain in the hammer wheel until the fine powder particles are produced, which is able to pass through sieve. So continuously the impact by the hammers responsible for breakdown of the powder particles. Now let's see the construction of the hammer wheel. Hammer wheel consists of four major parts. The first part is hopper. So what is meant by hopper, we will discuss with the help of diagram. So this is hopper. Hopper is present at the top. So what is the role of hopper? Hopper is useful to load the powder material in the hammer wheel. So coarse powder material is loaded in the hammer wheel with the help of hopper. And you can see the shape of hopper. The shape of hopper, this is hopper. So shape of hopper is funnel shape. Hopper is funnel shape part or a provision in the hammer mill, which is helps in the loading of powder material. Later on, the next part, which is major part of the hammer mill, it is grinding mechanism. You can see here. So these are the hammers. So hammers are actually responsible for grinding of the powder material. So the hammers rotates at high speed. Actually, hammers are connected to the rotor, which is later on connected to the central shaft. So shaft rotate at high speed results in a high speed rotation of the hammers, and these high speed hammers strike on the particle and results in an impact, and this impact is responsible for breakdown of the powder particle. So hammers are responsible actually for the breakdown of the powder particle. What about the material which is used for fabrication of these hammers? So hammers are generally made up of stainless steel in order to avoid the rusting. Stainless steel is resistant to rusting or corrosion, and that's why, because the different powders comes in contact with the hammers. So sometimes powders are acidic in nature, sometimes powders are basic in nature, and that may cause the corrosion of the hammers. And to avoid the chances of corrosion, the hammers are made up of stainless steel. Okay, so in detail we'll discuss about the hammers, and later on the next part is a sieve, which is placed at the bottom. You can see here. So there is a provision to replace this sieve based on the final powder particle size required. If you require very much fine powder size, that then you can place a fine sieve. If you require quite coarse powder particle, medium size coarse powder particles, then you have to place the sieve accordingly. So there is a provision to remove this sieve and place this sieve again. So grinding mechanism, as we discussed earlier, the grinding mechanism is hammers. So hammers are actually responsible for grinding of the powder particles. So hammers are connected to central rotating shaft, as we discussed in the diagram, and the motor shaft is operated by motor. So motor is actually responsible for operation or rotation of the shaft. So motor rotates at high speed, and so motor rotation results in a rotation of the shaft. So rotation of shaft results in ultimately what will happen? The hammers are rotated. We will see with the help of again diagram. So hammers are connected to rotor, then again finally connected to shaft, and shaft is connected to motor. So motor actually operates this shaft, and later on as shaft rotate, the hammers are also rotated. Then next important thing, so these hammers you can see carefully in this diagram. We will see hammers are either rigid, means immobile, means fitted on the rotor, or either swing position, means what will happen, we'll see. So suppose this is a rotor, this is rotor, okay, and this is hammer. So rigid hammer means hammer can't move, and swing hammer means hammer can move like this or like this. So hammers can move, so this is known as swing position. And rigid hammer means hammers are fixed, hammers can't move, just shaft rotate and later on hammers rotate. So you can see in the diagram also, the hammers are in the swing position, means what, this is original position of hammers. Due to rotation of shaft, hammers change its position and hammers again come at new position. Again hammers move back to the original position. So likewise the rotation of the hammers, the rotation of the hammers may take place, and this is known as swing position. So either hammers are rigid or swing. So which is the material used for fabrication of hammers? That is stainless steel, already we have discussed. What about the shape of hammers? Hammers are either bar or stirrup shape. What is meant by bar or stirrup shape? So this is the rotor, this is bar shape hammer. Stirrup shape hammer means like this. Either hammers are bar shape or stirrup shape. Both types are available. Then either rigid or swing, already we have discussed. Either hammer is at fixed position rigid, or hammer can swing like this. So either hammer rigid or swing type. And the bar shape hammers, which are specially used in dry granulation, preparation of granules of the tablet by using dry granulation technique. Let's see the third part of the hammer mill is sieve. So sieve, where sieve is fitted? Sieve is fitted at the lower end of the drum, lower end of the hammer mill. And this sieve, as we discussed earlier, you can replace it. You can replace the sieve according to desired powder particle size required. If you require fine powder particle of your product, then we require fine sieve. If you require intermediate size of the product, then accordingly you have to replace the sieve. Last part is a discharge chamber. What is the role of discharge chamber? Discharge chamber is useful for removal of the product from the mill, and this discharge chamber is fitted below the sieve. So below the sieve, discharge chamber is fitted. These are four major parts of the hammer mill. Let's see the working. Working is very much easy. So shaft rotates at high speed. As the shaft rotates, who operates the shaft? Shaft was operated by motor. So shaft rotates at high speed and results in a rotation of the hammers. So what about the rotational speed? RPM, rotation per minute. So rotation per minute of the shaft is 8,000 to 15,000 RPM. It's at high speed the shaft rotates. And this rotation of the shaft results in a breakdown of the powder particle. So first of all, we have to start the hammer mill. So as we start the hammer mill, motor rotates the shaft and shaft rotates the hammers. Later on, the material to be grind, means the coarse powder material, is loaded in the hammer mill through which part? Hopper. So as the material is loaded in the hammer mill through hopper, what will happen? The high speed hammers which were initially rotated, these high speed hammers strike on the powder material. It results in a breakdown of the powder material due to the impact simply. So hammers strike on the powder material, results in a breakdown of the powder material. So rotation of hammer is continue, means the rotation of the hammers is continue till a solid powder material is grounded to fine powder size, means till the all powder particles are collected from the bottom. The rotation is continue. The powder particles pass through the sieve that indicate the powder particles we have reduced to the size with the help of hammer mill. So finally, the fine powder particles, as we discussed earlier, pass through the sieve, and these fine powder particles are collected through discharge chamber. So due to the rotation of the hammers at high speed, what will happen? Due to the rotation, continuous rotation, the heat is generated, and the heat generated in the hammer mill that may cause the breakdown, thermal breakdown of the heat sensitive material, means the thermolabile drugs. And that's why hammer mill is not suitable for those drugs which are thermosensitive. Thermosensitive drugs means those drugs which undergoes the degradation in presence of heat or at high temperature. So those drugs which are undergo degradation at high temperature, these drugs we cannot grind with the help of hammer mill. Why? Because the heat is generated inside the mill. Let us see the uses of the hammer mill. Hammer mill is used for both wet grinding and dry grinding of material at pharmaceutical industry, especially used for grinding of the sugar, then medicinal plants. So barks, leaves, roots of the medicinal plant. First important thing, suppose we have medicinal plant, we have collected medicinal plant, then first thing what we have to do? First of all, we have to subject it to drying to remove all moisture content, because we have already discussed what is the effect of moisture on size reduction. So subject to drying, later on subject to cutting with the help of cutter mill, and later on load in the hammer mill. This is a in general way how the medicinal plant are converted into the powder. Different parts of the medicinal plant are converted into powder. So hammer mill is used at last after cutter mill for breakdown of the, for generally for to reduce the size of the medicinal plant. And later on hammer mill is also used for grinding of drug and excipients. What are the advantages? Capable of grinding many types of material, especially powder material like drugs, various drugs you can grind with the help of hammer mill. Later on excipients, easy to install. Why? Because occupies very small space. Small space required for the hammer mill. That's why hammer mill is very much easy to install. Easily you can install at minimum floor space. Later on, maintenance and cleaning is very much easy. So while selecting mill, we have to consider all parameters. After completion of the size reduction, we have to keep the mill clean, means you have to maintain in proper condition. So maintenance is very much easy. So small space requirement, this is one more important advantage. And particle size of the product you can control by controlling which parameter? So by controlling the speed of rotation, so there is a provision to adjust the speed. So according to the size of product required, you can select the speed of the rotation of the hammers. Later on, by selecting proper type of hammer. So as we discussed earlier, hammers are available in the bar shape or stirrup type designs are available, either rigid or swing type. So by selecting proper hammer type, you can control the particle size, as well as most important thing, by selecting proper sieve. So according to product size requirement, you have to select the sieve. If you select the fine sieve, you will get fine powder particle at the last. If you select quite moderate, means quite intermediate number sieve, then you will get a intermediate size powder particles. So by controlling the rotational speed, by selecting proper hammer type, and by selecting proper sieve, you can control the powder particle size which you will get at the last. Let's see the disadvantages. As we discussed earlier, first important disadvantage that is heat. So due to high speed rotation, the heat is generated, and that may cause the breakdown of the thermolabile drugs. So these thermolabile drugs you cannot grind with the help of hammer mill. For thermolabile drug, hammer mill is not suitable. Why? Because that may cause the degradation of thermolabile drugs. Then if you are using thermolabile drug, then we require additional cooling facility in order to maintain the temperature. If you provide the cooling facility, then the effect of heat, especially heat, will not generate, because temperature will maintain at constant level, and then you can grind the thermolabile drugs. But without cooling facility, you cannot grind the thermolabile drug, because that may cause the degradation. Feed rate, at how much rate you will feed the material in the hammer mill, the feed rate must be controlled, because the excessive loading of the hammer mill may cause the choking of the mill, and that's why it is very much essential to control the feed rate of the material in the hammer mill through hopper, because if you not control the feed rate, that may cause the choking of the mill. That's why it is very much essential to control the feed rate. So here we have finished the first type of mill, that is hammer mill. The second mill, which is used for uh, grinding of the powder material, is ball mill. So why the name of mill is ball mill? Because it consists of stainless steel balls of various sizes. Generally, the mixture of stainless steel balls of various sizes are utilized. So because the stainless steel balls are responsible for breakdown of the powder particles, the name of mill is ball mill. So in ball mill, the grinding and mixing of the powder material is carried out with the help of stainless steel balls, and this is used for preparation of various dosage forms, especially the different powders, either for topical application or for oral administration. So it is used for grinding as well as blending combination of all powder material. So let's see the principle of ball mill. So as we discussed earlier, ball mill consists of the stainless steel balls. So why stainless steel is selected as a material? Because it avoids the chances of corrosion. Again, the different materials comes in contact with stainless steel balls, acidic material, basic material, that may cause the corrosion, and that's why, to avoid the chances of corrosion, the material which is used for fabrication of the ball is stainless steel. What about the principle of size reduction? So ball mill work on the both principle, attrition as well as impact. Let's see what is meant by impact, what is meant by attrition, and how the impact and attrition takes place in a ball mill. So what is meant by impact? Impact means the particle is heated by the moving object of the mill. So either in hammer mill, moving object is hammers. This is one representative hammer. In ball mill, moving object is stainless steel balls. So here the stainless steel balls, suppose this is one stainless steel ball and this is powder material. So what will happen? This is one powder particle. So stainless steel ball fall on the powder particle and results in a breakdown of the powder particle into fine powder particles like this. So this is stainless steel ball. So stainless steel ball fall on the powder particle and results in a breakdown of the powder particle into fine powder particles. So stainless steel balls falls on the powder particle, and this stainless steel balls, this is metallic stainless steel ball. Due to the heavy weight of the stainless steel ball, the powder particle break into fine powder particles. Next mechanism of the particle size reduction using hammer ball mill is a impact. Impact already we have discussed. Next is a attrition. So how attrition takes place, that we will discuss. So ball mill basically consists of a cylindrical chamber like this, hollow chamber, and in cylindrical hollow chamber the stainless steel balls are placed. This chamber, or we can call it as a drum, this cylindrical drum is mounted on the metallic frame like this, and the cylindrical drum rotates along its longitudinal axis. So what will happen? Due to the continuous rotation of the stainless steel chambers, first important thing takes place, that is balls falls on the powder particle, and this is known as impact. Second thing takes place, the stainless steel balls, suppose these are stainless steel balls and this is the inner wall of the drum. This is drum. So inner wall of the drum and the stainless steel balls. So due to the rotation of the drum along with its longitudinal axis, what will happen? The balls also roll on the wall of the drum. So continuous rolling of the balls also takes place. And due to the continuous rolling, what will happen? The powder particles are break between ball and metallic drum. So in between the gap which is exists between the powder particles and metallic drum, the attrition of particle takes place. Sorry, in between the gap which is exists between the balls and metallic drum, the powder particles are crushed and results in a breakdown of the powder particles. So impact means the stainless steel balls falls on the material, and attrition means due to the movement of stainless steel balls in a grinding shell or drum. So powder material is simply grind between the balls and inner wall of the drum. This is attrition. So impact means the stainless steel balls fall on the material, and attrition due to the rolling of the balls inside the drum. Due to rolling, the powder material is crushed between the drum and the balls. Let's see the construction. It consists of only two major parts. Which are the two major parts? The is a first part is a it consists of two major part. Which are the two major part? The first part is a shell or a drum. So shell or a drum, it is hollow cylindrical stainless steel shell or drum. So balls are made up of stainless steel. In addition to this, the drum is also made up of stainless steel. We'll see. So as we discussed in the diagram earlier, this is hollow cylindrical drum, and these are the stainless steel balls. So balls are placed in the hollow cylindrical drum. This drum is mounted on the metallic frame. This is metallic frame. Drum is mounted on the metallic frame, and this cylindrical drum is connected to the motor. Cylindrical drum is connected to motor. So motor actually responsible for breakdown of the powder particles. So how the powder particles are reduced to the fine size, already we have discussed. Two major mechanisms are there. The first is attrition, second is impact. So ball mill consists of a hollow cylindrical drum. It is made up of stainless steel. Then the balls also made up of stainless steel. The balls are placed in the cylindrical drum, and this drum is mounted on the metallic frame. You can see in the diagram, metallic frame is there, and the drum is connected to the motor. So motor, actually, what is the role of motor? Motor is actually responsible for rotation. So cylindrical drum is connected to motor. Okay. So motor actually rotates this cylindrical drum along the longitudinal axis like this. And due to the rotation of the cylindrical drum, balls will lift it at the top of the drum and again falls down, results in a breakdown of powder particle. That also we will discuss. So only two components, major components are there. First is the cylindrical drum and second is the stainless steel balls. So cylindrical drum, as we discussed earlier, it is mounted on the metallic frame. So it is mounted in such a way that it can rotate along its longitudinal axis. Inner wall of the cylindrical drum is lined with or coated with chrome or porcelain. What is the role of chrome or porcelain? This chrome or porcelain is coated on the inner wall of the drum. So inner wall of the drum is coated. Inner wall of the drum is coated with a chrome or porcelain. What is the role? Again, to avoid the rusting. Because if the inner wall of the cylindrical drum undergoes rusting, these fine particles of corroded material, fine particles of corroded material may mix with the powder particles, and that may result in a contamination of powder material. And that's why, to avoid the rusting of the cylindrical drum, the inner wall is coated with either chrome or porcelain. The rotation of the drum, as the drum rotates along the longitudinal axis, what will happen? The balls glide. Simply ball lifted towards the top and falls on the material and results in a breakdown of the powder particles. So this is in general image of the ball mill, and intentionally I have included because you must know how the actually ball mill looks like. So this is in general image of the ball mill. You can see this is central rotating drum, and this rotating drum consists of the stainless steel balls, and this rotating drum is connected to motor. Next, second component of the ball mill is stainless steel balls. So stainless steel balls are actually responsible for breakdown of the powder particles. Drum just hold the powder material and stainless steel ball. Actually the powders are break with the help of stainless steel balls. Balls are made up of either chrome steel or stainless steel or ceramic. These materials actually are resistant to corrosion and rusting. That's why these materials are used for fabrication of the balls. How much is the capacity? Actually volume occupied by the, not capacity, the volume occupied by the stainless steel ball, 30 to 50% of the drum volume. Total 30 to 50% of the drum volume is actually occupied by the stainless steel balls. This is very much important. This figure is important because that may ask in the MCQ type question. So 30 to 50% of the drum volume is actually occupied by the stainless steel balls. So now, which size of the stainless steel ball is preferred? Whether it is fine or large. Okay. So large size ball, if you are using large size ball, that produce the coarse powder material, whereas small size balls produce fine. Generally, in ball mill, the mixture of both large as well as small size ball is used. So certain number of stainless steel balls are large size, certain number of stainless steel balls are small size. So mixture of both large as well as small size stainless steel balls is used. Let's see the working of the ball mill. So how actually ball mill works? So first of all, the material is fed in the drum, central rotating drum. Later on, the fixed number of stainless steel balls are introduced in the drum, and later on, this is quite spelling mistake here. This is drum. So first of all, powder material is loaded, and later on, the fixed number of stainless steel balls are loaded, and later on, drum, not a drug. Drum is closed with the help of lead. So this ball mill is completely closed mill. That's why it is used, because It avoids the chances of dust generation and contamination. So first of all, we have loaded the powder material. Later on, we have loaded the stainless steel balls, and later on, we have closed the central rotating drums. Later on, the drum is allowed to rotate along the longitudinal axis. The rotation of drum results in a movement of the balls inside the stainless steel drums, and results in a breakdown of the powder material. So what we have to discuss in detail here, the speed of rotation, at how much speed we have to rotate the drum. So what will happen if the speed is low, if speed is too much high? So the in diagram what we have discussed, the central rotating drum like this. This is actually 2D diagram. Actually 3D diagram, the drum is like this. So this is side view of the drum. These three diagrams are nothing but a side view of the drum. The drum consists of stainless steel balls like this. So if you see from side, you will see these diagrams. So at low speed, what will happen? If the drum rotates at low speed like this along the longitudinal axis, if drum rotates at low speed, what will happen? The balls will not lift it towards the top of the drum. Ball will just glide over each other, and effective size reduction will not take place. So no effective size reduction. Why? Because here you can see the balls are not lifted towards the top. Balls just remains at the bottom side of the drum. So balls will not lift it towards the top, and as ball not lifted towards the top, ball will not fall on the material. That's why impact will not take place here. And as impact not takes place, no effective size reduction. At high speed, what happens? If this drum rotates at high speed, then what will happen? All stainless steel balls move towards the periphery. All stainless steel balls move towards the periphery, means at circumference, due to centrifugal force. Due to centrifugal force generated, all stainless steel ball move towards the periphery. Again, here the power, due to high speed, the stainless steel balls are lifted towards the top, but the stainless steel balls will not fall down. Why? Because of high speed and due to centrifugal force. Here, centrifugal force is force acting away from center. Okay, so away from center, here stainless steel balls are lifted towards the top, but these stainless steel balls are not fall at the bottom, and that's why here also impact will not take place. So no impact in low speed. At low speed also no impact, and at high speed also no impact. So due to lack of impact, the particle size reduction will not take place in effective manner at both low speed as well as at high speed. At low speed, what will happen? The ball just glide over each other. At high speed, ball move towards the periphery due to centrifugal force. No impact takes place, and results in a no effective particle size reduction. But at correct speed is also known as critical speed. What is mean by correct speed? The speed at which the balls lifted towards the top, and again balls fall at bottom. So here, as ball lifted towards the top and falls on the powder material, here impact will take place, and due to the impact, the effective size reduction you will get, and this speed is known as critical speed. Sometimes question asked in the MCQ type question, this speed is also known as critical speed. So correct speed of the rotation of the drum is very much essential. What will happen at low speed, what will happen at high speed, that already we have discussed. So that's why correct speed is very much important. What are the advantages? It produce very much fine powder material compared to hammer mill. Size reduction of toxic material is possible. Why? Because the mill is entirely closed. No dust generation. Dust generation will not take place. So, and as the dust generation not takes place, it will not cause the any toxic effect of the material to the health of the workers, those who are operating this particular ball mill. So it is completely closed mill. That's why the dust generation will not take place. Next, both wet as well as dry grinding is possible. Both types of grinding you can do it. Easy to install. The space requirement is also less space requirement, and due to less space requirement, it occupy very much less floor space, space as well as installation is very much easy. Sterility means microbial free environment of the powder you can achieve because the drum is entirely closed. So no contamination. See, contamination of powder will not take place. How? Because chamber is entirely closed, as well as no contamination of room where actually ball mill has operated. Why? Because again no dust generation and chamber is entirely closed. So no hazardous health effect on the workers will also hazardous health effect will not occur. So bar and rods may use instead of balls for sticky material. If the material is sticky, that may stick to the balls, and that may actually hinder the movement of the balls. And that's why for sticky material, instead of balls, the bars and rods may use. Instead of the spherical balls, the spherical balls you can replace with a small size rods for sticky material. Due to rotation, see, the drum is made up of stainless steel and the balls are also made up of stainless steel. Continuous rotation of the balls takes place, and that's why it creates a lot of noise. The machine is a noisy machine. Okay. Then after utilization of the mill, it is necessary to clean all balls as well as inner wall of the drum, and which is difficult to clean. It is difficult to clean the balls as well as drum. Maintenance is also quite difficult. Soft and tacky material, sticky material, cannot be grinded because that may hinder the movement of balls. So if you are using the sticky material, the movement of ball will not take place because sticky material helps in the sticking or adhesion of the balls on the inner walls of the drum, and that's why you cannot do sticky material. See, due to continuous use of the ball mill, what will happen? The wearing of ball takes place, wearing, tearing of balls and drum inner wall takes place, and that's why that may cause the contamination. The material of the drum balls in the form of fine particles may enter in the final powder product, and that may cause the contamination of material. So these are the various disadvantages of ball mill. So in this lecture, what we have discussed? We have discussed two mills, ball mill as well as hammer mill. Now in next lecture, we will see two more mills, that is roller mill and fluid energy mill. Thank you.